Have you ever really stopped to think about what the food on your plate, the spoon in your hand, and the very air you're breathing all have in common? It sounds a bit like a riddle, right? Well, it's a scientific concept that's so fundamental, it connects pretty much everything. Today, we're uncovering this hidden world of mixtures. So let's really dig into that question. Your food, your spoon, and the air. What on earth could possibly unite all of them? Let's investigate the clues, and we'll start with something we all know. First up, a plate of poha. You can see all the individual parts, can't you? The flattened rice, the peanuts, the little bits of chili and lemon. They're all tossed together, but a peanut is still a peanut. Each part keeps its own identity.
Okay, next clue, a sprout salad. It's exactly the same idea here. You can easily spot everything. The sprouts, the tomatoes, the onions. They're combined for sure, but they haven't fundamentally changed into something new.
And now for a total curveball. Metal utensils. They look completely solid, totally uniform, nothing like a salad, but they hold the exact same secret. So, have you figured it out yet?
The answer is, they're all mixtures. It's that simple. From the obvious ingredients in your lunch to the perfectly blended metals in your cutlery, mixtures are absolutely everywhere.
And that's exactly what we're going to explore. We're going to see how most things in our world aren't just one single pure substance, but are actually combinations of many different things. So what exactly is a mixture? Well, the scientific definition is when you combine two or more substances, but no chemical reaction happens. Think of it like this. The substances are just physically hanging out together, and each one gets to keep its own original properties. Now, here's the thing. Not all mixtures are created equal. They fall into two big categories, and the main difference really just comes down to what you can see. So on one hand, we have non-uniform mixtures. That salad is a perfect example. You can easily see all the different bits and pieces. On the other hand, we have uniform mixtures, like salt dissolved in water. The parts are spread out so perfectly, so evenly that you can't see them separately at all. And this is a fantastic visual comparison. On the left, there's that non-uniform salad, but on the right, you have a uniform mixture of sugar and water. It just looks like plain water, but we know the sugar is in there, just invisibly and perfectly mixed in. Okay, let's tackle the biggest uniform mixture of them all, one that's literally all around us, but is completely invisible. Yep, we're talking about the air. You see, the air we think of as just air is actually a really complex mixture of gases. It's mostly nitrogen, about 78%. The oxygen our bodies need makes up only about 21%. And then you've got these little trace amounts of other gases like argon and carbon dioxide. All of them are perfectly mixed together, creating our atmosphere. But how can we be so sure? We can't see any of these gases. How do you prove that something like carbon dioxide is really there? Well, there's a simple and pretty clever experiment for that. It's called the lime water test. Basically, you create a clear solution called lime water. Then you just leave it out in a dish, completely exposed to the open air. And then you just wait. And here's the magic. That completely clear liquid on the left slowly transforms into the milky, cloudy liquid you see on the right. This visible change is our proof. So what's actually happening on a chemical level? What's going on is a specific chemical reaction. The lime water is reacting with the carbon dioxide that's in the air. This reaction creates tiny, new, white particles called calcium carbonate, and those particles are what turn the water milky. It's definitive proof that CO2 is part of the air we breathe. So we've gone from the invisible mixture of gases in the air to a solid one. Let's go back to those metal utensils from the beginning. They're a special kind of uniform mixture called an alloy. Alloys are basically mixtures of metals, and sometimes nonmetals. This chart shows some really common ones. Brass is a mix of copper and zinc, bronze is copper and tin, and stainless steel is a mix of iron, chromium, and more. By combining these, we create materials with way better properties, like more strength or resistance to rust, than the individual metals have on their own. And this is not a new idea. It's ancient. This quote from the Charaka Samhita, an ancient Indian text, shows that alloys like bronze weren't just for tools. They were even used for medicinal purposes, believed to improve health. That's a truly amazing piece of our scientific history. So we've seen mixtures in our food, in the air, in our metals. Let's kind of pull back now and look at the big picture of why this all matters so much. The sheer variety of mixtures is just incredible. You can have a gas in a gas, like the air, a gas in a liquid, which is what gives your soda that fizz, a solid in a liquid, like seawater, and even solids mixed in other solids, like the alloys we just talked about. They truly form the fabric of our physical world.
You know, this isn't just a textbook concept. Understanding mixtures is fundamental to so many different things. It's the basis of cooking, it's the reason we can breathe, it's the secret behind manufacturing super strong materials, and it's a key principle in developing life-saving medicines.
And that leaves us with one final, pretty thought-provoking question. If almost everything around us is this complex tapestry of mixtures, what does it even mean for any substance to be truly pure? It really makes you think, doesn't it?